integration. We learned a new way to integrate. Okay, hey, are we good? Great. So we saw how to reverse the order of integration if the integral is cannot be computed one way. We saw that it may be computed in another way by reversing the order of the integration by describing the region slightly differently. Let's do an example. Let's continue by doing examples to this. And this is from the book as well. I think I'll do all these examples from the book. So if the book has examples on this, I'll do them all. And I think they're pretty easy. So if you guys want the time, do you want to take the time to try and do it? Or okay, so please take 2 minutes to try and do it. And I'd appreciate if you don't talk in these 2 minutes. Okay, just focus on your paper or stay silent. Okay? If you don't want to work, that's fine, but try not to disturb others. Okay, so let's time this. So how much time do you think? 3 minutes is good? 4 minutes? 4 minutes is good for this? And then I'll be passing and asking you questions. If you wish, I could put another one. Should I put another one? Let's put another one. Okay? If you have questions, please raise your hands. I will pass back. Okay? Okay, so shall we stop? Are we good? Great. So, I mean, square root y sine y. If you want to integrate that, I mean, it looks a bit ugly, right? I'm not sure integration by parts work here, does it? Did anyone try it by parts? So what is the thing to do? What is the thing to try? To switch the order of integration, right? So what do I have to do here? What's the first thing we do? We sketch the region of integration. So y goes from where to where? Y goes from, what are the curves that I need to draw? Y is equal to x squared, and y is equal to 1, right? And x goes from 0 to 1. This is a good sign. You know that the intersection is 1, 1 here, so. Great. Y goes from x squared to 1, and x goes from 0 to 1. Can you sketch this region? Where is it? This one or this one? 1 or 2? 1. Now if I describe it another way, is the parabola y is equal to x squared. And I want to describe y between two constants and x between two functions of y. What are these two functions? So where does x go to? It goes from here to here, right? Agree? X goes this way. What is this line here? The y-axis. X is equal to? X is equal to what? The y-axis. 0. Very good. And what is this curve? This is y. This y is equal to x squared. What is x in terms of y? If x is positive, then y is positive, and y is positive. What is x in terms of y? X squared of y. Great. So x is bounded between two functions of y, 0 and square root of y. And where is y vary? Y varies between 0 and 1. Are we good here? Questions? Great. So let's hope that we can get a nicer integral. I think we do get a nicer integral. Square root y sine y dx dy, right? I took the order. X goes from 0 to square root y. Y goes from 0 to 1. How do I integrate square root y sine y with respect to x? What is that? That's a constant. So I just have to integrate 1 from root y to 0. What do I get? So I get 0 to 1 root y times root y sine y dy. What is that? It's integral from 0 to 1 y sine y dy. How do I proceed to integrate this? By parts, right? So this is u v prime, right? What is the integral of u v prime? This is just u v minus the integral of v prime u minus v prime is 1, u is minus cosine. Right? Are we good here? Are we good? Is that clear? Let's check. I mean, always check that your derivatives are correct. So what did I get? So it's minus y equals y minus antiderivative or plus antiderivative of cosine y dy. Differentiate this to get minus cosine y plus derivative of cosine is minus sine. Derivative of minus sine times y. So plus cosine y. Okay. So what do you get? You get minus 1 cosine 1 plus an antiderivative of cosine minus minus. What's an antiderivative of cosine? Sine plus sine 1. So it's sine 1 minus cosine. Is it clear? Yeah? Great. Let's do this one here. Are we good or no? Yeah? Is the integration correct? Okay. Now how do I evaluate the second one? What's the first thing to check? The first thing that you can do, what is it? Is there a mistake in integration? Could be. I could have messed it up. Did you guys find this? Yes. Sine 1 minus cosine 1? Yeah. Can I help? Yeah. It's good.
I was just asking, like, how did you go from where you have 1 to the square root of y to where you have 2 square root of y?
Here?
Like, what did
Great.
you do?
You agree this is a constant with respect to x, right? You can take it up. Suppose you have 5 here. Integrate 5 from 0 to square root 5. What do you get?
Oh,
Okay? This one here. Okay? Great. Here, how do we start? First, we try to integrate. Can we integrate to the x4? It's a bit difficult to find a closed form for an antiderivative of the x4. So what do? We try to reverse the order of integration. In order to do that, what do we do first? We sketch the region. So I have x and I have y. So what I want x is equal, goes from where to where? X goes from cube root of y to 2. So I have to draw the line x equal to. That's easy to draw. Agreed? Now what else do I have to draw? X is equal to cube root of y. I mean, it may be a bit difficult to draw this, but really, what is this curve? Y is equal to x cubed, you agree? Cube both sides. Y is equal to x cubed, and y is from 0 to 8. So y is equal to x cubed goes something like that, right? Oh, man. Right? Is it?
Yes.
Yeah. And y goes from 0 to 8. Great. So what do I want? Which part do I want? So y goes from 0 to 8. This is good, because what is cube root of 8? 2, okay? So this is 400. Great, so I want x to be at most 2, and at least cube root of y. Where is my region, 1 or 2? Everybody, where is my region? Where is my region? We all see that? X is smaller or equal to 2, and bigger or equal to cube root y. So where is my region? This one or this one? 1 or 2? Everybody, do we see that? Great. Now I need to express this region. I had here y between 2 constants and x between 2 functions of y. What do I need to express it in terms of what? What do I need in my final answer? Like, what do I need to express it? How do I need to express it? Here I had x between 2 functions of y and y between 2 constants. What do I need to express it? Want to say something? No? Who wants to help? Who wants to help? X is between two, here x is between 2 functions of y and y is between 2 constants, right? What do I need to do now? If this doesn't work, yes?
Change them and you make it go this x to x instead.
So x is between, so what is between?
So x is between 0 and 2.
X is between 0 and 2, very good. And
y is between 0 and x cubed.
Y is between 0 and x cubed. We all agree that if you draw this region, these are the same regions, this same region. Great. We agree or not? Everybody, do you agree with this or no? X between 0 and 2, sorry. And y is between what and what? 0 and x cubed dx4 dx dy. Sorry, dy dx, sorry. Right. Great. How do I integrate from 0 to x cubed e to the x4 dx dy? E to the x4 is, with respect to y, is constant, so I can take it off. And how do I integrate from 0 to x cubed dy? It's just x cubed, right? I have 0 to 2, x cubed, e to the x4 dx, and I can find the antiderivative for this very easily. It's just e to the x4 over 4, from 2 to 0, which is e to the 16 minus 1. Is that what you found? Yes, sir.
What if for the y, the lower bound is not 0?
What if for the lower bound is not 0? So you say here?
Yeah, somewhere there. So we would have to find solve for x at that point.
Yeah, you have to find the solve for x at that point.
And that would be the two bounds for dx.
Exactly. Maybe we can do that. That's a good question. We can try that? Should we try that? Sure. Oh, you mean for the y. So for the x, yes, that's going to be more interesting. Why is that? Because try to express it. This is this region. Oh, no, that's still fine. So x goes from cube root so you have to worry about this one. So you want here x goes from cube root y to 2, right? And you want x to be bigger than this value. Right? So you may have to split into two regions in the x direction. This region, this rectangle, and this rectangle. So it's a bit tougher to write them this way. It's not as nasty. Okay, you see that? It's easily doable. If you put the y equal 1 here, it's easily doable. Yeah. But it may not correspond to something nice here. Okay? Yeah. Okay. Should we do one more? We do one more of this. I think I did all the ones in the book. I think this example will do it all in the book. But let's do it. So please, I cannot emphasize how important this is. Okay? Like it's very important. I expect you to do such a question in 7 minutes, 5 to 7 minutes. That's fair, right? That's fair. 5 to 7 minutes. Let's do one more. Let's do the last one. Where we do 1. Y, oh man, goes x cubed minus 1. Dx dy. Okay, let's do this. Yes, sir.
Yeah, y over 2.
Y over 2, yes. Yes. What's the first thing we check? We check whether we can integrate this. Find a closed form for an antiderivative of this function. Can you do that? Cos x cubed minus 1 dx. Is this nice to integrate? Can you integrate that? Cos x cubed minus 1. Can you integrate that or not? Can you integrate that? Looks bad, huh? Cos x cubed minus 1 is not good, not easy to integrate. Great, so what do we do now? We try to reverse the order of integration. What's the first thing we do? We graph it, we sketch it. Are we good or not? Okay, let's sketch it. X is varying between what? So y is between 0 and 2, that's good, that's easy. And x is varying between y over 2 and 1. So what are the two curves I need to draw? X equal 1, this is a nice line. And I need to draw x equals y over 2. What is x equal y over 2? How do I sketch that? How do you sketch this? It's a straight line, very good. Yeah? And then how do you sketch that? Sure, but of course, straight line. I can sketch it this way, right? Straight line is straight. So y is equal to 2x, right? So does the origin belong to this point? To this line? 0, 0 belong to this line? And then what is the point another point that belongs to this line? If x is equal to 1, what is the value of y? 2. So this is the point that belongs. This is a triangle region, right? So this is the line x equals y over 2. And I have that x goes from y over 2 to 1. Whereas y goes from, okay, I guess I followed it. This is this region, right? You agree? You see why it's not the region above? You see why? If you were to describe the region above, it would be x goes from where to where? 0 to y over 2, and y goes from 0. Yeah, x goes from 0 to y over 2, that's good. And y goes from 0 to 2. Very good. Okay, great. Now, how do I need to, I have x is between two functions of y. We agree? What do I want now? I want to express it in terms of y between two functions of x. What is the below function? So y is vertical, goes from where to where? What is this line in terms of y? Y is equal to x. So y goes from where to where? 0 to x, very good. So 0 y to x. And x needs to be bounded between two constants. What are the two constants? 0 and 1. Very good, thank you. And let's try that. So x is between 0 and 1. Y is between 0 and 2x. Y cos x cubed minus 1. dy dx. And then we integrate. So how do I treat the cos x cubed minus 1? Constant, right? Because I'm integrating with respect to y. We agree, everybody? How do I integrate y dy? What is the next derivative of this one? Y squared over 2. Right? So what can I say? This is just cos x cubed minus 1 times y squared over 2 from y is equal to 2x to y is equal to 0. What is that? We all agree with this or not? What is that? So 2x, 4x squared over 2, what is that? This is 2x squared minus 0, so we get the integral from 0 to 1. 2x squared cos x cubed minus 1. Can I integrate this? Is this integrable? It is. Can I find a closed form for an antiderivative of this? Yes, I can. Let me do it here. What's a closed form? It's a sine x cubed minus 1. So times 2 over 3, right? Yeah? From x equals 1 to x equals 0. Right, so what do I get? I get minus, or 2/3 sine of minus 1. Okay, is that clear? Is that good? Great. I think we did everything in the book. So all the examples, yes?
Isn't it minus 2?
Derivative of sine is cosine.
Yeah, but you're doing, when you plug in 1, you get 0.
Oh, true. Thank you very much. Minus 2/3 sine. Yes. Let's double check. Yeah. Thank you very much. Minus 2/3 sine. Minus 1. Thank you. Yeah. So it's 2/3 sine. Are we good here? Is it clear? Okay. So please be comfortable with this. I don't know if we should do one more, but are we actually comfortable with this or not? Okay. And let me see if I can find one more example. Yeah, I mean, I think we did everything possible. Or we do one more or not? Let's do one more. 0, 1, square root. Okay, but here you have to help me a bit more. You have to be a bit more. 0, 1. These are all from Stewart. Y squared. Okay, EX squared over X cubed. What's the first question we ask ourselves? Guys, everybody, in the back. Yeah. What's the first question? Is it easy to integrate? Can we integrate this easily? E to the x squared over x cubed. Do you know an antiderivative how to integrate this? No. So, how do I do this? What can I start? I can try to I squared, and then I sketch my region of integration in order to switch the order, right? Let's switch the order. So x, what are the curves that I need to draw for x? Everybody, for x, what are the curves that I need to draw? X is equal to what? Square root y, and x is equal to 1. So let's draw them. And x is equal to square root y. Is it easy to draw or not? What is that? Y is equal to x squared, right? Y is equal to x squared. So this is y is equal to x squared. X is equal to square root y. And y goes between what and what? 0 and? Y goes between where and where? 0 and 1. So if x is equal to 1, what is the value of y? 1, right? And this is a good way to check that your region is nice. Now, what is the part that I want? I want x to be between square root and y and 1. Where is my region? Here, 1 or 2? Everybody. Everybody. 2. Right? Are we good? Yeah? Are we good? So, how do I describe this in another way? I want to go vertically, right? This is horizontal. X is between two functions of y. I want y between two functions of x. So where does y, what is the lower bound for y, everybody? Y is naturally bigger or equal to 0. And what is an upper bound for y in terms of x? X squared, very good. And what happens here? X goes between, I need two constants for x. What are they? 0 and 1. Very good. So let me do this. So x goes from 0 to 1. Y goes from 0 to x squared. Y dx squared over x cubed dy dx. Of course, you have to check that y is nicely integrable in terms of x, right? In terms of y, right? When you switch the integration. Can I integrate this nicely with respect to y or not? E to the x squared over x cubed. How do I treat this now? As a constant. So I have to integrate y dy from x 0 to x squared. What is that? So I can take that 0, 1 dx squared over x cubed times y squared over 2 from x squared 0. So what do I get here? I get x4, right, over 2. I get e to the x squared over x cubed times x4 over 2 dx. What is that? I mean, here there is something. Do you see the problem actually? Do you see the problem here or not? Do you see a problem? What is the problem? At 0, right? Anyways, x cannot be 0, but let's ignore this. Okay? Let's ignore this and do our cancellation. Okay? It will integrate out nicely. It will integrate out nicely. Why is that? Because the x's will cancel out. Okay? You have experience. Okay, great. So what do you get? Integral 0 to 1. 1/2 x to the x squared dx, right? And then what do you get? You get e to the x squared, so you have 1/2 over 4. From 1 to 0, you get e minus 1. Okay? Are we good? Great. Okay, let's ignore this here. It works out nicely. Okay? Great. Anyway, enough with this switching of order of integration. Please not do this. I emphasize it a lot. The book has no more examples, literally. Okay, so I did all the examples in the book. If you want, you can do one more, but I have to try it. Is that okay? Is that okay? Everybody, is that okay?
Yes.
Is that okay? Yes? Okay? Okay? Yeah, sure. It's an improper integral, right? You've seen improper integral in class, right? Kind of the same. Okay, we will visit this again. Okay? And most of the time, yeah. Okay, so it's actually a nice type of improper integrals. Anyway. Great. So let's do some examples again. I'll move away from this and do some examples, very basic examples, and then we'll move on to polar coordinates. Okay, so polar coordinates, but we didn't see them in class 2, right? Did you see them? No. 0. 0, 0, 0, okay. Great. Okay, let's do a small exercise. Find the volume under the surface. I don't know, I hope this integrates nicely actually. And above the triangle. With vertices. See what you look at? 1, 1, 4, 1, 1, 1, 1, 4, 1, 1, 2. What's a good way to do this? How do we do this? What's a nice way? First of all, what do we do with the region? We sketch the region. Great. So 1, 1. What is that? This is 1, 1. 1, 1, 1, 1, 1, 1 is here. 4, 1. X is 4 and y is 1. It's a nice right angle triangle, right? And I have to find the volume under the surface. Now, above this region, what did we see? The volume. First of all, is x, y positive above this region? Is z positive? If x and y range in this triangle, is x times y positive? Yeah, it's clear, right? Because x is positive and y is positive, so x, y is positive. Great. First check. Great. What do I need to integrate? I need to integrate my function x, y over this region. You agree? So the volume is, since, let's call this R, let's call this region R, since x, y are positive for x, y, and R, what is the volume? It's double integral over R of fxy dA. Agree or not? Everybody. Now, how can I describe my region?
Half a square.
Sure, you can do that, half a square, but that doesn't mean that the integral is half, right? That's a good point. So I could describe it as half a square. Well, is it a square? I don't think half a rectangle you can, yeah. But that doesn't mean the integral is half. So how do you describe this? Remember the Lagrange multiplier? Yes, sir.
The function for all, like part of the domain of the triangle and 0 outside.
Sure. Very good. Awesome. So it's a function that assigns 1 if you're inside the triangle and 0 outside. Awesome. Very good. More specific, inside the triangle. How do you check if something is inside the triangle? I give you a point, let's say, the triangle or on the boundary, let's say. Either triangle or the boundary, that's fine. The boundary is okay. If I give you a point I give you a point 3, 1, is it on the triangle or its boundary? Yeah. If I give you a point 3, 2, is it? So this is 4, 1, and this is how would you describe it? If I tell you y is between two functions of x, how can you describe this? How can you describe these two functions of x? Y is between two functions of x. Okay, yeah? That's right. Right? What is the equation of this line? Y is equal to 1, right? This line here, let's call this 1, 2, 3. 1 is the line y is equal to 1. 2, what is the equation of the line 2? What is the slope? Y is delta y over delta x. What's delta y? Delta y is minus 1 over delta x. What's delta x? 3 times x minus 1 plus 2. Agree? Yes or no? Let's double check if it goes through these 2 points. 4 minus 1, what is that? 3. Minus 1/3 times 3 is minus 1, plus 2, 1, I get this point. Let's check this point. Of course it goes through this point because this will cancel out and you have 2. Okay? And 3, what is the third line? X equal 1. Of course, this is not true, right? Because it's not the entire line. I'm looking at the segment here. You agree or not? Am I looking at the entire line here? Or I'm looking at the segment of the line? Segment. So y is minus 1/3 x times x minus 1 plus 2. What 2 values I'm considering? What are the values of x that bound this line? 1 and 4. So 1x 4. And x equals to 1. This is the line x equal to 1. Am I considering the whole line x equal to 1 or a segment? Segment between what and what? Y? 2. And y is equal to 1. Between 1x and 4. Now it's clear how we're going to describe it. There are many ways of describing this, but what's one nice way? If y is to vary between two functions of x, y can vary between two functions of x, and x can be bounded between two constants. What are the two functions of x here? You have them right there. Y varies from 1. Y varies from 1 to minus 1/3 x minus 1 plus 2, and x varies from 1 to 4. You agree you can do that? You agree with this? If you sketch this region, you get this region. We agree or not? What's another way of doing it? What's another way of doing it? I want to express it in terms of x. I want x between two functions of y. Any questions? Which one? This one? First one or second? First one. Y varies between this line and this line. Okay? What is the equation of this line? What is the equation? Okay? Well, whereas x varies between 1 and 4. Okay? Now, if I want x to vary between two functions of y, I can do that, right? X goes bounded from this function of y to this function of y. What is this function of y here? X is equal to 1, very good. Or, and then what is this function of y? How do you find this function of y? What do you do to solve for x, right? So what do you get? You get y minus 2. So let's see, you get 2 minus y times 3 plus 1, right? Is that what you get? And y varies between where and where? Where does y vary from? From? 1 to 2. We agree? Yeah? Y is going up from 1 to 2. Whichever way you choose to integrate, it should give me the same answer. So, do we check that or it's fine? Which one do you prefer to start? I personally prefer the second one because there are no fractions. But who knows what happens here, right? So let's do that. So what do you get? You get 6 minus 3y plus 1. So you get 7 minus 3y. Is that what you get? Let's double check. If x is 4, what is y? Here? Let's double check. Let's do it. So I get 1/3 times x minus 1.
Never mind.
Is that good? Is that good? So plug in y is equal to 1. If y is equal to 1, x should be equal to 4. 7 minus 3, x is 4, that's good. And if y is equal to 2, x should be 1, right? 7 minus 6 is 1. So for a line, you just need 2 points. If your 2 points satisfy the equation, then you got the right equations. Okay? Great. Which one do you want to integrate? You choose. Here, is the integral easy actually or not? xy, you can integrate it whichever way you want. So which way you want? 1 or 2? The second? Let's go for the second. Thank you. 1 to 2. Great. X goes from 1 to 7 minus 3y. xy. What do I have? dx, right? dy. Okay. Great. Now how do I integrate this? Y is treated as y is constant, right? So I have y, and I have x squared over 2. From where to where? 7 minus 3y to 1. It's going to be bad. Oh, yeah, it's going to be bad. Is that right? Is that right or not? Any questions? Any questions? No. Great. So let's do that. So it's 7. Oh, man. It's not going to be bad. It's just going to be statistic expand, right? So it's 7 minus 3y squared over 2 minus 1/2 dy. Then what is that? That's to integrate, right? how do you integrate this one? You expand it, right? You see that? You expand this one, you get a polynomial easy to integrate. So let's do it. So you have to integrate 0, 1. So 9y squared minus 42y, right? 9y squared minus 42y plus 49, right? Yeah? Times y, so it's 9y cubed minus 42y squared plus 49y. Yes, sir. Anybody else? Yeah?
I have a question. How did we go from one equation to
Did I mess up something?
we go down right from integral one?
Oh, shoot.
And then we went to
That's fine. That's good. I didn't start integrating. Thank you very much. Thank you. Good thing you didn't mess it up because you didn't start integrating. Plus 49y minus y over 2. Right? Is that right? Can you double check? 9y squared minus 42y. Yeah, is that good? Everybody, are we following? Yeah? Great. So 9y cubed over 2 from 1 to 2, that's good. Let's split it. Plus, so minus 42 over 2, what is that? This is minus 21, right? 1 to 2 here. 49 minus 1 is 48 over 2, 24. 48y over 2 is 24y. Okay, so let's integrate. Y cubed, y4 over 4. So it's 9 halves. What's y4 over 4? 2 to the 4. Is it clear? Is there a mistake or not? Yes, sir.
49 over 2, where's the 24?
9 over 2, where is it?
When did 49 divided by 2, that doesn't give you 24.
You have a minus y over 2, right? Yeah, you have a minus y over 2. Okay? Is it clear or not?
Yeah, minus 1 over 2, right?
So 49 minus y, 49y minus y is 48y. Over 2, 24. Yeah, is that good, everybody?
Yeah.
Great. So what do you get? 9 half to the 4 minus 1 over 4, minus 21. Let's see, 2 cubed minus 1 over 3, plus 24, 2 squared minus 1 over y squared over 2 over 2. Let's see if we can do that. 2 to the 4 minus 1 is 15, right? So this is 15. Oh, 15 times 9 over 8. Man, that's going to be bad. 15. So 15 times 9 over 8. I mean, it's not that bad. 7 times 7 minus 49, right? Plus 12 times 3 plus 36, right? 3, 12, 36. Now minus 49 plus 36 is minus 13. So it's 15 times 9 over 8 minus 13. Let's do that. Let's double check. We have it good. 15 times 9 over 8 minus 13. So you cannot cancel, so it's 15 times 9. Is there a mistake? Everybody, is there a mistake? Are you guys following? Over 8. So 15 times 9, 135, right? 13 times 8, it's 104. Yes, sir.
So little mental math that we're doing right now, whatever you say about the exam.
Pardon me?
The little mental math that you're doing right now, all that mental math, because it's not calculated the exam. Does that mean the same level, or do we expect?
You have a paper. I don't have a paper. Okay, so for you it should be easy. Okay? I can make mistakes for you, like you. Okay? A paper is easier on the board. 135 minus 104, what is that? 13 times 6 is 104, right? 26, 26, 26 is 104. 135 minus 104. 31/8. I hope the book has the answer for this one. Man, I hope it's not. Yeah, that's right. 31/8. Okay? Okay. So if a multiple choice, you're expected to, I will make sure that the answer that you get is, like, the options will be simplified. Like, I want you to get to a simplified one. Okay? And this is not that bad. Is it bad? It's just plain. Okay, great. Great. Now, let's do something else. Okay, now, do you want me to check that it gives you the same answer if you do it this way or not?
No.
Or it's fine? It's fine? It's gonna be uglier. You noticed that, right? It's gonna be so... Whoa! Yeah. Okay, let's do another one. It's also a nice one from the book. But I want you to always remember your calc 2. Okay, I want you to remember your calc 2 here. And I give you a question. Find the area enclosed by y and the x-axis. Okay, this is a classic question in Calc 2. What did you do here? So, if I tell you find an area between two curves, we're above the x-axis and below one curve, right? You have to integrate a function. Yes or no? Great. Now, usually I give you an interval, and you have to be sure that this function is positive on that interval, right? So that you can interpret it as an area. Now, if I give you this question, there's something I'm not giving you. I'm not giving you the x values. You agree? But how do you do this? Yeah? So what was it? You find the intersection between the curve y is equal 9 minus x squared and the x-axis. How do you do that? You set them equal to each other. So the x-axis, what is the equation of the x-axis? It's y equals 0. How do you find this? So, or usually it's also a sketch is very helpful here. So you have this one. What point do you have here? Minus 3. And what point do you have here? 3. Great. What do you integrate? Where do you integrate? From minus 3 to 3. 9 minus x squared. Easy problem. Right? And the function is indeed positive from minus 3 to 3. Right? Is that good? We're going to do the same thing here, but in 3D. It's going to be a bit more difficult. It's a bit more conceptual. Maybe well, it's a bit more abstract, I guess. There is some sketching involved. The good news is that your sketching doesn't have to be that good. It has to be just rough, a rough sketch. Okay? And then you'll be able to find it. So the idea here, if I give you a problem like that, so in the problem before, I gave you the rectangle or whatever, the triangle, over which you have to find the volume under the surface, right? Here I will give you a problem where I don't give you the rectangle, where I don't give you the region, but you have to find it. Here, did I give you the interval over which you have to integrate? Did I give you the interval? No, but you found it. Okay? So we're going to do the same thing there. I'm just going to give you a surface, and then you will be able to, or you'll have to find the region over which you'll be integrating. So find the volume. You do something very nice, actually. of the, let's see, of the tetrahedron. X plus 1 plus z is 4. Enclosed by the coordinates plane. No. Enclosed by. And here this is easy to draw. And the plane 2x plus y plus z is equal to 4. Let's try to sketch this. You want y where? Y is here, x is here, and z is there. Okay, so if x and y are 0, what is the point on this plane? If x and y are 0, what is the point on this plane? 4. Z is equal to 4, right? 0, 0, 4. Right? Now, if z and y are 0, what is the value of x? 2, right? So if x and y are 0, x is equal to 2, z is equal to 4. And then if z and x are 0, what is the value of y? 4. Okay? You're looking for that volume. Do you see that? How many points you need to draw the plane? To draw a plane, how many points you need? 3 points that are none of the same line, right? You found them. You found 3 points not on the same line, so you can draw the plane. I'm telling you, I want the volume under this plane, right? And between the coordinate axis. So it's like a pyramid, right? It's a tetrahedron, right? You've seen the word tetrahedron? Yeah? Yeah? Tetrahedron. This is called tetrahedron. Great. Now, am I integrating a function of x and y? Is z a function of x and y? Can you solve for z here? Yeah? What is z? What is the function you're integrating? 4 minus 2x minus y. Okay, great. Now, you want the region above, so bounded between the coordinate planes. So really here, if you look at the picture, is x positive or negative? Positive. Is y positive or negative? Everybody, do you see that? X is positive, y is positive. What else is positive? What else must be positive? Remember your 9 minus x squared example. Z must be positive, right? X is positive, y is positive, because this is the volume we're looking at. And at the same time, Z must be positive. You're integrating above this region. Yes, sir.
Is the line supposed to be crossing the vertex of the triangle, or like the
You mean go down?
No, you mean the other one, the one pointing at
Which one?
you see the line pointing at what?
Here?
Yes, is it supposed to be crossing?
Oh, you mean like that?
Yeah.
Yeah, sure. Sure. You agree with this? This is the region you're integrating over. Did I tell you what region you integrate over? No, but just the info I gave you, you know that z must be positive, and x must be positive, and y must be positive. You know that this is the region you're integrating over. Let's sketch this region. So it's 2x plus y is less or equal to 4, so you need to draw the line. 2x plus y is equal to 4, right? Draw the line to x plus y is equal to 4. What is that? If x is 0, y is 4. And if y is 0, x is 2. Agreed? Everybody, do you agree? Isn't this the same line here? What is the point here? 2, 0, 0. 2, 0, 0. 0, 4, 0. Are indeed the same points. When you solve for z equals 0, you get this line. But you also want x bigger or equal to 0 to y bigger or equal to 0, so you're restricted to this segment. Is that clear? Is that clear? Now, how do you describe this? How do you describe this region? Which way do you want to go? X or y? You can describe this region in two ways, right? X goes between two functions of y, and y between two constants. So this is 4, this is 2. Or x between two constants, and y between two functions of x. All of them, you have them here. Do you guys see this? You guys see that? So which one do you prefer? You want x between two constants and y between two functions of x? Whichever you want, whatever you want. So if y were to vary between two functions of x, where does y vary? From here to what line? Y varies from here to this line, right? You agree? So y will be bigger or equal to 0. Look at here. What is the equation of this line? It's 4 minus 2x. Now, x varies from what number to what number? 0 to? Yeah, someone said it. 0 to 2. Right? We'll do another example. I mean, do you want me to integrate this or it's fine? So what is the function? So I have to integrate. X is from 0 to 2. Y is from 0 to 4 minus 2x. 4 minus 2x minus y, sorry. dy dx. Yes, sir.
You always put the variable that's in terms
Yeah,
of the other one.
of course.
Right?
Yes. Otherwise, it doesn't make sense, right? Because you'll get a function of x, right? Okay, should I do the integration or that's easy to integrate? That's easy to integrate. Let's do another example. I'll write it here. This may be a bit easier to visualize, but harder to evaluate, maybe. I need the surface. Find the volume of the solid above the xy plane and below the surface. That is 1 minus x squared minus y squared. You remember we had seen something like that, right? How? Yeah, you remember that? When we look at tangents, or maybe, I don't know, anyways. So, let us remember, in calculus 2, I tell you find the volume below the curve y equals 9 minus x squared and the x-axis. What did you do? You solved the intersection, right? You found the points and you integrated between the 2 points where the function is positive. You agree? That's what you did, right? Let's just remember this. You found 3 and minus 3. Your function is positive between minus 3 and 3, so you integrate between that region. You agree or not? That's what you did. Now we're going to do the same thing. The problem is that I have the surface, but what I don't have is the region. You agree or not? Of course you need that to be positive. You agree or not? Now this surface, I can draw it this way basically. I don't know if this drawing is clear, but okay? So I don't know, I mean, you know, if you have a water balloon, just like cut it, like, you get it, right? What do we have here? What is the intersection? If z has to be positive, what can I say about x squared plus y squared? If z has to be positive, what can I say about x squared plus y squared? It has to be less or equal than 1. If z is positive, right? So let's say z is 0, what can you say about x squared plus y squared? Is 1. You agree? If z is 0, okay? If z is 0, then x squared plus y squared is equal to 1. You all agree? You're going, so you have a parabola like that, paraboloid. Oh man, it goes something like that. Okay? Z is 0 if and only if x squared plus y squared is equal to 1. Great. Now, where is z positive? Inside the circle or outside the circle? Look at the inside the circle. X squared plus y squared is less or equal to 1. So 1 minus x squared plus y squared is positive. Do you agree or not? Everybody, do you agree? 100%? Do we see that? So what is the region you're integrating over? You're integrating over? Are we good? In the back, are we good? Are we good with this or not? Always remember the same example you did. Remember this example. 9 minus x squared and the x-axis. How did you find the volume? First you found the intercept, the intersection between the 2 curves, and you found the region where this is positive, right? It's from minus 3 to 3 and you integrated there. That's what you did. You agree? That was easy, wasn't it? Now we're going to go slightly harder, but we're going to do the same thing. Instead of points where the 2 things intersect, I'll have a curve. In that case, the curve is the circle. And instead of an interval, I'll have a region. This is positive on an interval, right? It intersects at 2 points. This intersects at a curve, and it's positive in a region. In what region for x and y is z positive? Inside the circle or outside the circle? Inside the circle. Is that clear? Great. So I have to integrate z, 1 minus x squared minus y squared, right? dA. Well, how do I describe my region? How do I describe what I said here, what I wrote here? How do you describe the disk, the unit disk? How do you describe it? How do you describe the unit disk? How do you describe the circle? X squared plus y squared is equal to 1. Inside the circle, x squared plus y squared is less or equal to 1. Right? So you integrate over this region. Is it clear or not? Remember, Calc 2, you had a curve. To find this area, what did you do? You solved for the angle, you solved for the intersection, and you had 2 points. Here, instead of points, what will you have? You will have a curve. If you solve z equal to 0, you'll get x squared plus y squared is equal to 1. Then, you looked at an interval where this function is positive. Instead of an interval, you will get a region. Okay? Is that clear? Is that clear? Is that clear?
Yes.
Great. So, I have to evaluate this interval. Yes, sir.
Is it like looking at it from the top?
Sure. You look at it from the top. So, what do you mean? No, what do you mean from the top? Like up, like that? Well, I mean, you can look at it from everywhere in this case, right? Look at it from the top. Yeah, you can look at it from the top. You can look from anywhere. It's going to be the same, right? I mean, if you solve z bigger or equal to 0, z must be bigger or equal to 0. You agree? So this means x squared plus y squared must be less or equal to 1. Okay? Are we good here? Is it clear? Is it actually clear or not?
Yes.
I personally took me 2 years to understand that, but it's good if it's clear. Is it good? Great. So now I don't want to evaluate this integral. Or you know what? We do more examples like that. Just one or two more examples. And then we'll start polar coordinates. Okay, let's do one more example. Find the volume of the solid above the xy plane and below the surface. Z is equal to 4 minus 2x squared minus 3y squared. Yes, sir. That's a good question. What are the bounds? Does it look tempting to integrate this? Are you tempted to integrate this? Doesn't look tempting, right? Why is that? Because y can vary from minus square root 1 minus x squared to square root 1 minus x squared, whereas x varies from minus 1 to 1. Is that good? Now, does that look tempting to integrate? It doesn't. I mean, you may still be able to do that, but we'll see a way how to integrate these things easily. Okay, very good question. Thank you for the question. Okay? Great. Now let's do this one. Let's do this one. This is going to be an easy one as well. Again, these are the easiest cases. How do you sketch the region of integration? Okay, sketch the region. Or just find the volume. Well, write down, set up the volume. That's of an integral for the volume. How do you do this? First, what's the thing you need? What's the thing you got to make sure of? That z is big. You got to find the region of in the xy plane above which you're going to integrate, right? Over which you're going to integrate. What do you need to have? You need to have that z is bigger or equal to 0. Are we agree or not? So what is the region? If z is positive, how can you describe the region?
2x squared plus dy squared and then what equals to 4.
Exactly. So integrate over 2x squared plus 3y squared, that's equal to 4. 4 minus x squared. What is that shape called? Do you know what the shape is called? It's called ellipse, right? Yeah? Have you seen this before? It's called an ellipse. You do some geometry with ellipses. They don't do that here anymore. And do you see that in Calculus 1? I don't think. In Pre-Calc we might see that a bit, but I don't think in Calc 1 you see this. This is an ellipse. Now, I don't remember how to draw them, to be honest. I have to plug in numbers and see, right? I mean, let's see. Do you want to plug in numbers? If y is 0, what is x? So it says equal to 4. If y is 0, 2x squared is 4. So So x squared is 2. So x is root 2 minus root 2. And if x is 0, y squared is, oh man, 4 over 3. So it's 2, oh, okay. I think you have one way to discern, like, if it's like that or like that. Anyway, it's not important. What's important is this one. Okay? You agree that this is the integral? Great. Now, okay, is this clear? Should we do one more like that? We do one more like that? Let's do one more like that. Allow me to erase this one, please. About the... Well, I mean, that's fine. Let's keep it this way. Above the xy plane. Find the solid above the xy plane, or up, well, that's not you know what, we can spice it up a bit. I would just say above in the first option, well, find the volume. That's fine. That's fine, let's try that. Anyway. Okay, now evaluating integrals of this type is actually not easy, right? As your friend suggested here, how do I describe these two regions? They're going to get ugly, right? You notice this. So how can you describe this? Y goes from minus root 1 minus x squared to plus root 1 minus x squared, and x goes from minus 1 to minus 1. I mean, these you may be able to evaluate, but I'm not sure. Even I'm not sure. But we have to find a way to evaluate these two things. Yes, sir.
Can you not use the symmetry to move one of the bounds and just multiply by 2 for the volume?
Let's try to avoid symmetric arguments. I mean, you have formulas for the integral of x squared, right? So, like, you integrate on half a circle. You could do things like that, yeah. But, so for example, say you had an integral of x here, for example. You have to integrate x over this one. This is 0, right? And what's the first integral? The first one, the integral is the area of the circle, which is 5. Okay, so we will do arguments like that, but for now we'll stay away from this. Okay? Great. Now let's move on to polar coordinates. It's really that's going to help us motivate, that's going to help us evaluate integrals like that in an easy form. Let's pick a point xy in the plane that is non-zero. How else can I characterize xy? One way to characterize it is by giving you the coordinates of the point. Do you agree or not? If I give you the coordinates of the point, then you know where you are. Yes or no? Now if I give you that you are at distance 1 from the origin, is there a unique point satisfying this? If I tell you that your point is at distance 1 from the origin, how many points do you have? Infinity. That's the unit circle, right? So if I give you the distance is not enough. You agree with this? If I tell you that your point xy is at distance 10 from the origin, is that enough to characterize it? No. Now suppose I give you that it's at distance 10, and it tells you that the angle, that this angle is 10 degrees. Can you locate your points? Everybody. I tell you it's 5 away from the origin, and this angle with the x-axis is 10 degrees. Can you locate your points? This is the point of polar coordinates. Polar coordinates is a change of coordinates. So we switch coordinates. Right? I mean, what's the trigonometric circle, the unit circle. It's r, you've seen that this, the radius is equal to 1. And how do you characterize a point on the trigonometric circle? By the angle, right? Now, we'll just not do it only for the trigonometric circle, we'll do it just for all circles. And by doing it for all possible circles, you will cover the entire plane. You see that? Everybody, do you see that? Have you seen this? You haven't seen this. Polar coordinates. Let's go on the unit circle. We're now on the unit circle. Okay, if I tell you, locate the point theta equal pi over 4, do you know how to locate it? Theta equal pi over 4. How do you locate it? You draw an angle here, pi over 4, right? And this is theta equal pi over 4, right? Now I'm just asking you to do it for any number r. So x squared plus y squared is equal to r squared. If I tell you theta equal pi over 4, it's going to be the same thing. Question? No? Do you agree or not? Do you see that? Okay. So, if I were to find x, if I were to call this distance r, and this angle theta, what is x and y in terms? What are x and y in terms of r and theta? What is x? X is this value, right? X is r cos theta. And what is y? Y is r cosine pi over 2 minus theta. Everybody, guys. R is cosine pi over 2 minus theta, which is r sine theta, right? Every point that is not the origin can be represented uniquely as a pair of r and an angle theta. Anybody, have you taken complex numbers? Have you seen complex numbers? So z is equal r to the I theta. Have you seen this before? Z is equal to r to the I theta. Have you seen that? Really, this is the polar coordinate, right? If you haven't taken, that's fine. X is r cos theta and y is r sine theta. Is it clear? If I tell you a point, if I give you a point, let's see. Who volunteers for a number? Who wants a number? Volunteer for a number? Number? Say number. 12, okay. Find r theta. If x, y is 12, and someone else give a y value. Seven, sure. Great. What is r in that case? R is just, let's say 5, okay? It's nice. It will give a nice answer. 5 will give a nice answer. What is r? R, letter r, is square root of 5 squared plus 12 squared, which is 13. Okay? You agree? So x is 12, 5. R is 13. Now what is theta here? So how do you do that? I mean, there's a... Yeah. So you take 5, 12. Okay? How do you find the angle? X is 12, it's 13 cosine theta. Y is what? Is 5. Y is 5 sine theta. Pardon me? X is, sorry, 13 times that, thank you. What is X here? X is 12, right? And Y is 5. So cos theta is 12 over 13, and sine theta is 5 over 12. So in what quadrant is theta? Theta is in the first quadrant, obviously, right? What is the value of theta? This is arc cos of 12 over 13, or arc sine of 5 over 12. Okay? Yes, sir.
What's the point of the 2x over there?
What is the point of?
2x.
Where's 2x?
That's all left. Next to the circle.
I think it's from the previous question. I had 2x squared plus 3y squared plus 3 equal to 4.
Okay, the previous question.
Yep. Okay? These are the polar coordinates. Okay? These are the polar coordinates. It's just a change of coordinates. Any number different than the origin can be represented uniquely as a pair r and theta. Okay? Cos 2 material, I think. Anyways. But we're gonna stick to this. Really, this is what you have to know. Okay? Great. Now, remember before, I had to integrate over the unit disk. What's the use of all of this? I had to integrate over the unit disk, which is a bit complicated to represent. What's up? Can I help you? No? Okay. I had an integral over the unit disk. I mean, it looks very bad, right? The way we represented it. It looks very bad. Now, let's take the unit disk. This is x and y. Okay? Now, let me sketch this. What do you prefer? Let's put R here and take it. Let's look at the unit disk. The angle varies from where to where. How can you characterize the unit disk? Theta varies from where to where on the unit disk? 0 to 2 pi, right? Theta varies from 0 to 2 pi. Now, R varies from where to where? R varies from where to where? R is always constant. The radius is always constant. Yeah, so R varies from where to where? 0 to 1, right? Because you have x squared plus y squared, that's equal to r squared. Do you agree or not? X squared plus y squared is r squared cos squared plus r squared sine squared, which is r squared. Right? This is just r squared is less or equal to 1. So since r is positive, this means that r is less or equal to 1. So this means that r is between 0 and 1. Great. So r is between 0 and 1. And theta is between 0 and 2 pi. Oh, let's keep it this way. We agree or not? Now, with respect to x and y, this is what? This disk is a bit complicated. You agree or not? Yeah? It's a bit complicated to express it in terms of x and y. I mean, it's not complicated, but you know, when you transform it to polar, this disk looks like what? Like that? This is length 2 pi, this is length 1. It will look like a rectangle. So the polar coordinates transform a disk in the xy plane to a rectangle. Transform the unit disk into a rectangle. Now, what do we know about rectangle from our calculations? Aren't they easy to integrate over? You can integrate easily over rectangles, right? It's just two constants. I mean, this is a more motivation. It's not always the case, but in that case, it's a rectangle. Great. Now, I mean, there is at least a motivation to that, but let's just convince ourselves of this fact. Here, I'm working with dx dy. You agree or not? This is dx dy, right? dA. And here I should be working with what? dr d theta. Very good. I have a change of coordinates from x and y to r theta. Now, can I say that dx dy is equal to dr d theta? Is that logical? The two are equal? That's definitely not, right? It's definitely not the case that they're equal. It's not obvious that they're equal, right? Take one variable. You say x is equal f of u. What is dx? Dx is what? F prime of u du. You agree or not? You can change coordinates, but you have a penalty to pay. What is the penalty to pay that you have? F prime of u du. Right? Now, what is the analog of the derivative that we have seen? The Jacobian. You remember this or not? This is the penalty that you have to pay for moving from dx dy to dr d theta. And it's very simple. Look at this. Right? How do you do this? Like, the absolute value of the Jacobian times dr d theta. Of course, the full derivation of this you will see in Math 264. Of course, for a circle, it's easy to motivate this by drawing things and trying to convince yourself. But the idea is that this is the penalty you have to pay. Well, it's not a penalty, but it's more like the factor you have to scale by. Okay? I mean, I don't think it's very difficult to convince yourself of this, right? Because dx is f prime of u du. Let's play the role of the derivative. Right? I mean, you write this. This is what you do, right? You say this is this. Right? This is what you do. Now, what the Jacobian plays the role of this one, right? This is really a Jacobian 1D, and this one plays the role of this one. What is the Jacobian for x and y and r and theta? I'm pretty sure we computed that. You remember? We computed this. If you look 2-3 pages, well, I don't know how many pages before. We computed that. What is the Jacobian? Let's do it. So del xy, del r theta. What is that? Del x del r, what is that? Del x del r is what? Del x del r is what? Cos theta. Del x del theta is what? Minus r sine theta, right? Del y del r is what? Oh, wait. Del x del r, del x del theta, right? And then del y del r, what is that? Sine theta. And del y del theta is cos theta. What is this determinant? Oh, this is r. What is this determinant? R. What is the absolute value of the Jacobian? Absolute value of r is equal to r. So now I've been asked if the book has a section on Jacobian, and I think they do actually, but it's not, yeah. But anyways, okay. So I don't know how this is derived in the textbooks. I mean, of course they give some motivations, but these are the polar coordinates. Anyways, okay. Great. Now we'll do some examples. Okay? Now, let's do a small check. if I want to integrate over this region, this is the area of the unit disk. What answer will it give me? 5 r squared, right? This is the area of the unit disk. You agree? When you integrate one, what do you get? The area. What should you get here? 5. 5 r squared. What is r squared? 1. You get 5. Now let's switch this to polar. X squared plus y squared is equal, less or equal to 1. What does it become in r and theta? R is less or equal to 1, and theta is between 0 and 2 pi. So r is between 0 and 1, and theta is between 0 and 2 pi. What happens to my dA? dA is dx dy. What happens? R d theta. Great. Now, could I split this integral into a product of two things? Yes, I could. Right? It's 2 pi times the integral from 0 to, oops, sorry, the theta here and the r here. It's 2 pi times the integral of r from 0 to 1, r squared over 2 from, and you get 5. Very nice. Very easy. Should we do more examples? Should we do more examples where you could actually verify your results? So what's the volume of a ball? You know that a ball in 3D. Have you seen this? 4/3 pi r cubed. Have you seen this volume? Have you seen this formula? The volume of a ball is 4/3 pi r cubed. Anybody saw this before? Yeah. So let's try to check this. Find the volume of, we'll find the volume of a ball in another way, but of the solid below the hemisphere and above the xy plane. Okay, so I want the volume of half a ball of radius 1. The answer should be 2 pi over 3, right? Have we seen the volume of a ball before? It's 4/3 pi r cubed. Here r is 1, right? Just write x squared plus y squared plus z squared is equal to 1, right? This is just x squared plus z squared is equal to 1, and z is bigger or equal to 0. Okay? Yeah? You see that? Everybody, do you see that? This is this. Okay? Great. What do I have to integrate? I have to integrate, what is my region? Z needs to be positive, of course, but Z needs to be defined. So my region is still x squared plus y squared is less or equal to 1, right? So this is my problem, this is my ball. My half. Okay? Great. So Z will double integral dx dy. And this is bad, right? This is bad. Integrating this may be bad. But let's switch to polar. X squared plus y squared less or equal to 1 becomes what? Everybody, x squared plus y squared less or equal to 1, what does it become? This is the unit disk. What does it become? The unit disk becomes what? R varies from where to where? 0 to 1, and theta varies from where to where? 0 to 2 pi. Great, so I have to integrate. R is from 0 to 1. 0 to 2 pi, so this thing here became a nice rectangle. let's remember what's x. X is r cos theta, and y is r sin theta. So x squared plus y squared is what? Is r squared, right? Everybody. So I have a root of 1 minus, what is that here? Replace x and y by their values. What do you get? 1 minus r squared, right? Everybody, do we agree? Are we following? Square root 1 minus r squared. Now, I have to replace dx, dy. What is in terms of dr and d theta? R, dr, and d theta. Oh, wait a minute. Is that easy to integrate? Let's put the check over here. Is that easy to integrate now? What's the derivative of 1 minus r squared? It's minus 2r, which you can find here. And it's very easy to integrate. Great. And it's a rectangle. And so what you get is 2 pi, right? Times the integral from 0 to 1 of r square root 1 minus r squared dr. What is this? This is 2 pi 1 minus r squared to the 3 halves over 3 halves from 1 to 0. So what do I need to divide by? I need to divide by minus 2, right? I need to divide by minus 2. So what do you get? You get 2 pi, this doesn't matter. So 2 pi, the first one goes to 0, right? And then minus minus you get plus 1 minus 0 to the 3 halves over 3. You get 2 pi over 3. Yes?
Does it matter if it's r and r is theta or r is theta?
Does it matter here? You're in a rectangle. Right? It doesn't matter. You have two constants, Fubini's theorem. Right? So if you put the 2 pi outside, oh shoot, here yes, here it does, here I'm wrong. D theta dy. Right? Theta, is that what you meant? Yeah, okay, what I wrote is wrong. But you can still write dr here and r from 0 to 1, and d theta outside from 0 to 1. Okay, thank you. Yeah. Okay, now what's the volume of the sphere? It's 4/3 pi, the volume of the unit sphere, under the unit sphere, like the volume of the unit ball is 4/3 pi, right? Do I have a chalk here? Anyways, well, 4/3 pi. So the volume of half a sphere should be 2/3 pi, right? That's what we got. Okay, let's do more exercises. The exercises from the book. Let's see. Okay, maybe there are some tough ones in there. Okay. So should we move into hard ones immediately, or we do easy ones first, and then what do you guys prefer? Hard ones immediately? Easy ones first? Let's do some easy ones first. Pardon me?
Exam level.
Exam level one. I mean, exam you will have a mix, right? You can have easy things, you can have hard things. Like, you know, it's yeah, I think there is an order, there is a question on switching the order of integration on an exam. So you will switch the order of integration. That's going to be a question. I think, to my memory, it is going to be a question. So please not do this thing. Okay? Okay, and this one you will have a question on polar coordinates. So you should not do this thing. Great, let's do one example. evaluate double integral over R of x dx dy, where R is it says x squared plus y squared less or equal to 4, and let's do something nice. And y is between 0 and x. Really here, x has to be positive as well, right? Because y is not different. Let's go for free. Thanks. So I need the disk. What is the radius of this disk? Everybody, it's the disk of radius 2, right? Enter the origin. Now, what do I need? I need y and x to be positive, so I'm in the first quadrant. And y to be less or equal to what? X. This is the line y equal x. So how do you sketch this region? So I have a pizza, right? Two big parts. Well, for 1, 2, 3, 4, 5, 6. Am I looking at this one? This 1, 2, 3, 4, 5, or 6? Which one I'm looking at? 1, 2, 3, 4, 5, 6. What is the part I'm looking at? Everybody, what is the part I'm looking at? You agree? It's 1. I'm looking at the part 1. So it's the part of the disk where y lies between 0 and x. This one. Agree? Everybody, do you agree? Great. Now, is this nice, or I need to switch to polar? Well, I think you may be able to do it without polar. But let's switch to polar. R goes from where to where? 0 to, R goes from 0 to, everybody, R goes from where to where? 0 to R. Yeah, y goes from 0 to x, very good. R goes from 0 to 2, right? This is R squared is less or equal to 4. So 0, R2. Great. Now theta, where does theta go? Theta, where does it vary? Where does it range? Everybody, theta. Okay, guys, it's getting too loud, okay? R is getting, theta varies from where to where? Yeah, let's say.
0, pi over 2.
Pi over?
4.
4. 45 degrees, right? Yeah? Pi over 4. That's right. You see that? The line y equal x, what's the angle that the line y equal x makes with the x-axis? Pi over 4. Good. Okay, now what is x in terms of r and theta? X is r cosine theta, thank you. And what is dx dy? Dx dy is what? R dr d theta. That's very nice. Easy to evaluate, right? You have an integral over a rectangle. Isn't that nice? Yes? Yes, sir. You had a question?
Why is it not equal to the other last time?
Oh, shoot. Yeah, thank you. You're right. Thank you. Usually put the theta outside. I don't know why I put it. Thank you. So what do you get? I can split the two integrals, so it's integral from 0 to pi over 4. Cos theta d theta times the integral from 0 to 2 r squared dr. So what do you get? Cos theta, what's an antiderivative of cos theta? It's sine theta, right? So sine pi over 4, what's sine pi over 4? It's 1 over root 2, right? 1 over root 2. Times r cubed over 3 from 2 to 0 times 8 over 3, right? Yeah. Let's do one more. So usually when we have regions between circles, what is practical here? What is immediate? If you have regions on a disk, for example, between two disks or a disk that involves disk center at the origin, or for now, that involves disk center at the origin, what's the way to go usually? Polar coordinates. In general, I'm not saying every time it's that case. So let's give an example. Find integral over r sine x squared plus y squared dA, where r is the region How do you sketch this region? How many disks do I have involved in this region? Everybody, 2 disks. Very good. What's the first disk? What's the radius of the first disk? 1. What's the radius of the second disk? Radius is 2. This is r equals 2, and this is r equal 1. And I'm integrating over this region. So 1, right? So if r is a positive number that varies, whose square varies between 1 and 4, r varies between 1 and 2. So where does r go to? What are the bounds for r? Bounds for r are what? 1 to 2. R goes from 1 to 2. And what are the bounds for theta? Theta, the angle? 0 to 2 pi. Very good. Great. What is my function here? Sine of x squared plus y squared. What is x squared plus y squared, everybody? R squared. Sine of r squared. And it's bad to integrate, right? If you forget the r, you're not going to be able to integrate this. Now, what do I have the dA. What is my dA in polar coordinates? R, dr, d theta. Are we good? Yeah. R, dr, d theta. So let's do this integral. Let's evaluate this. It's 2 pi, right? 2 pi times what's the derivative? It's minus cos r squared over 2, right? Minus cos r squared over 2 from r is equal to 2 to 1. So what you get? You get 2 pi minus cos 4 plus cos 1 over 2. Okay, so it's pi cos 1 minus cos 4. Right? Unless I mess something up. That should be fine, I think. Is that okay? Great. Should we do one more? So we keep doing polar coordinates until the end? Yes, sir. Pardon me? Yes, sure. So what is the region I wrote? It's 1. I wrote it this way. You agree? What does this mean? This means that the square of a distance to the origin is between 1 and 4. If the square of the distance is between 1 and 4, what can you say about this? The distance is between 1 and 2. The distance is 2. Right? So draw the circle of radius 1 and the circle of radius 2. Good? Everybody, are we good? Great. Let's do one more. E minus x squared plus y squared, where R is the region. Fine. And the y-axis. In the book gives a hint, but I won't give a hint here. Again, does this look a nice integral? Is this a nice integral in general? Integrate e minus x squared and things like that. These are not nice to, or I think it's not possible to find an antiderivative, a closed form of an antiderivative. So, how do we do that? Yeah. So first, what do you recommend? What's the first thing we do? Sketch. Thank you. We sketch. And how does this curve look like? This looks a bit not nice, right? This root business. So how do you cancel the square root? What's one way to cancel the square root? Square the whole thing. So this is a part of the curve, so x is positive here. You agree? That x should be positive. And x should satisfy x squared is 4 minus y squared. Or x squared plus y squared is equal to 4, so the radius is 2. Right? So it's half that circle where x is positive. You agree? Bounded between the y-axis and this one, so this is the curve. Everybody, do you agree? Now, how do I describe this region? That's an interesting region. R, first of all, R goes from where to where? 0 to 2. You agree? R can go everywhere from 0 to 2. You have no restriction on that. But where are my restrictions now? My restrictions are on theta. Where does theta vary? Minus pi over 2 to pi over 2. Right? Or you can split that into two regions. You could say it's 3 pi over 2 to 2 pi, and then 0 and pi over 2. Do we want to do that, or we prefer minus pi over 2 to pi over 2? Minus pi over 2 to pi over 2, because you can do it in one shot, right? So, let's do that. You had a question? Yes? How I got the half circle? You agree with this? So, put this on this way. You got a circle of radius 2, right? Now, I want x to be positive. Okay, because they're only where x is positive. Okay? Great. So, theta varies from minus pi over 2 to pi over 2. And r varies from where to where, everyone? From 0 to 2. Great. E of minus x squared plus y squared, what does it become? E of minus r squared. My dx dy, what does it become? R dr d theta. I'll make sure I have the right order here. Is that easy to integrate? R e minus r squared, is it easy to integrate? Yeah? So it's what's an antiderivative for this? It's e to the minus r squared over minus 2, right? And then you multiply by pi. You agree? Multiply by pi. Let's see. Great. Two to 0. What do you get? You get pi. E to the minus 4. Minus 1 over minus 2. Okay? Great. Let's do one more. I think we're going to finish all the book, but anyways. Let's see. Yeah, you should expect things at this level. Okay? Things at this level are very fair. Okay? I think so, this is what I think. It's not, I mean, you know, if you just look at this and not practice at home, then you'll find it hard. If you practice, I think it should be very easy. We're gonna go a bit harder, but for now, we're gonna stay easy. Who likes trig integrals? Not me, but we have to do them, sadly. So, who volunteered for two numbers? Who volunteers? Who hasn't spoken today wants to volunteer for a number? Volunteer for a number? Yeah? 7, okay. 5. Fine. And then we have to worry about this and this, but that's fine, this is okay. Our R is the region. So what do we say, 5 and 7? We slice it a little bit, we can add some lines and that's fine, let's stick to this. If you want, you can do something as well, but we'll leave it to the next example. Great. What's the first reflex to do? What's the next thing to do? Sketch is a very good reflex, very good, thank you. What are the ranges that I have? 5 and 7. So my region, what is my region? It's this one, right? So what's a good switch? We switch to polar. R will vary from where to where? 5 to 7. Theta will vary from where to where? 0 to 5, very good, let's do that. Theta varies from 0 to 5. R varies from 5 to 7. What is y squared in terms of, what is y squared? X is r times theta. Y is r times theta. What is y squared? R squared times theta, times squared theta. And then what is x squared plus y squared? R squared, very nice thing happening. Great, what do I get here? dx dy, what is my dx dy? R, dr, d theta. Are we following? Are we tired? Yeah? It's a bit too much. Great. Now, how do I integrate this thing? How do I integrate this thing? R from 5 to 7. What happens here? How do I integrate this? R is from 5 to 7, so R squared over 2. So it's 49 minus 25 over 2, right? And I have to integrate sine squared theta, oh man. D theta, do you remember this? How do you integrate that? Oh man, I don't remember. What's the F angle formula? Very good, thank you very much. So this is 24 over 2, this is 12. So it's 1 minus cosine 2 theta over 2, right? Yep. Zero to 2 pi. D theta. What's the answer to this? The 1/2 goes to pi, right? Integrate from 0 to 2 pi. Right? Yeah? So, yeah. And then the cos theta integrates from 0 to 2 pi. What do you get? You get a constant times sine 2 theta from 2 pi to 0, which you get 0. Right? So you get pi. Right? Yeah? You get pi or no? Yeah? You get pi? Did we integrate that? So integrate cos theta over 2, what do you get? You get sine 2 theta times something, constant, do you agree? Sine 2 theta at 2 pi is sine 4 theta. Sine 4 pi is 0. At 0 is 0, so it doesn't change. So you get pi, right? Pi times 12, what is it? 2 pi times 1/2, it's pi times 12, it's, yeah, what is that? 12 pi. Let's do a few more. Should we do a few more? Let's do it. Oh man, this is a nice one. Oh, no. Okay, let's do one. I mean, you have to integrate by parts at some point. Yeah, I mean, you know. Okay, let's do more. Let me read this. What do we have here? We have sine, so let's put a cos. Centered as the origin. Do you want, I mean, how much time do you have? 10 minutes, okay, so I'll do it, because if you do it then, yeah. Okay, so at the origin of radius, someone give me a radius. Of radius what? 4. And then find. We'll do one more. Yes, you are. Great. Are these nice functions to integrate? No. So what do we switch? And what is the region, by the way, here? Is a very nice region that can be described by polar coordinates. What is the polar coordinates here? R varies from where to where? 0 to 4. And theta varies from where to where? 0 to 2 pi. Great, that's easy. Very good. So R varies from 0 to 2 pi. R varies from 0 to 4. And theta varies from 0 to 2 pi. What is that? Cos, what happens to cos? Square root of R squared, which is R, because R is positive, thank you. Cos R. What happens to dx dy? R d theta. What do I have to do here? What do I have to do here? Integrate by parts. Let's do that. So it's gonna be. So I have a 2 pi here. R cos R dr. So it's integral of. Yeah. Okay. So it's integral of u prime v. What is the integral of u prime v? What is the derivative that you pick? Always. R is the function, and the other is the derivative, right? Is that how you do it? R is the function, so you keep the R. What's the next derivative for cosine? Sine, right? Minus. Minus sine, right? Yep. Minus sine from 0 to 4. Let's be sure. How do we be sure? We differentiate. R sine R. What is the derivative of R sine R? U prime 1 V sine R. No, what? It's 1. I messed something up. Wait a second. No, that shouldn't differentiate. No, differentiate that. Sine R. Yeah, sine R plus R cosine R minus sine R. So that's good. Okay, that's good. 2 pi, let's do one more. So it's 4 sine 4 minus 0. We can do one more. Minus, what's the integral of minus sine? It's cosine. So plus cosine 4 minus cosine 0, right? We have time for one more? We do have time for one more. We have 5 more minutes. Is this correct? Can you double check the math? Is this correct? Yeah, you got this? Let's do one more. This looks interesting. What, yes, sir? Arctan? Very good. Very good. Yeah. So, oh, sorry. I forgot something, right? And 0x. Okay, because you have to learn where you're from. Yeah. So, what's the first thing we do? We sketch. So let's draw it. What are the radii? 1 and 2, right? So you have to draw the line between 1 and x, between 0 and x. And what is my region? It's between the two circles, right? But which part? Do you see that? Everybody, do you see that? So theta goes from where to where? 0 to pi over 4, very good. Theta goes from 0 to pi over 4. And r goes from where to where? 1 to 2, very good, thank you. Great. Now, what is that? Arctan of y over x is what? Tan theta, right? Y is r sine theta. X is r cosine theta. What is y over x? It's tan theta. Okay, now here we have to arctan varies from where to where? From minus pi over 2 to pi over 2, right? You agree? If your theta were here, then you should pay attention. Now, is my theta between minus pi over 2 and pi over 2? So what is arctan of tan theta? Theta, right? You guys see this? Yeah? So this is 0 pi over 4. Oh my god, I cannot keep the x dy. What do I have to do? R d theta. R d theta. So here what do I have? I have 0 pi over 4. Arctan of tan theta. Since theta is between minus pi over 2 and pi over 2, arctan of tan theta is theta, right? So I have theta d theta. And then 1 to 2 r dr. So what do you get? So pi squared over 16 times 1/2. So pi squared over 32. And then what you have 2 squared minus 1 squared over 2. So 3 over 2, right? Okay? So 3 pi squared over 64. Is that fine? Is that good? Is the math okay? Did you guys right? Okay, thank you very much. Tomorrow I'll be at your disposal, at your service, maybe an hour and a half extra, okay? If you guys have questions, I'll be. Great, thanks everybody.